Hey everybody, this is Trigonometry at College of the Sequoias in California. Math 154. You might have a different number at your school if you attend somewhere else. We're working on graphing translations of sine and cosine today. It's 6.4 in our book. You might be using a different book. It's probably in chapter 2 for you. And let me load up my video camera. There we go. And so let's just start exploring this idea. So 6.4 is on graphing translations of sine and cosine. Some of us like to call these the trannies. Shifting them left and right, up and down. So translations are vertical or horizontal movements of graph, of the base graph. And there's a lot of strategies people do. Some people find all the points, just graph the points. This is a quick rundown of how I recommend you do it. Graph y equals a cosine of bx or y equals a sine of bx with the dotted line. And then 2, do the translations with your 5 base points. And that includes the 2 endpoints, the midpoint, and the 2 quarter points. And then graph with it, and then draw the solid curve. Draw the solid sinusoidal wave. The form it's going to take when we do translations, this applied in algebra as well. We would have, with a base graph of y equals f of x, we would do y equals f of x minus, I'm going to use d and then say plus c. This results in shifting y equals f of x up c units and right d units. So the way I remember it is c is positive in equation, direction is in the direction of movement of graph, is in the positive direction. And then D is in the opposite direction. And I'm going to slide this up and add a little bit more on the next page. What I mean by that is if we have x minus d, we shift right. If we have x plus d, we shift left. So let me pause for a little bit. Pause your screen so you can write these out. Okay, I'll assume you did that. We're going to enhance it a little bit further. Let's just throw everything together. Let's add our A and our B in. So the final form, y equals A, we're going to use sine I'm going to say b x minus d plus c, or y equals a cosine of b times x minus d plus c. Again, the same stuff that we had before. A equals amplitude. B scales the period from 2 pi to 4 pi over 2b, or 2 pi over b if you learned it that way. C results in a vertical shift up. And D is a vertical shift, or a horizontal shift right. Noting that the equation says negative right now. And that's why I said opposite. This is minus. Minus is usually left. We go right. And positive is usually right. We go left. Because x plus d is really like x minus negative d, which is, so it's rewriting it like that. We're having a negative d, we're going left. So we can look at a few equations. Let's try it out and then go through some general rules. Let's look at some simple ones. Let's start off with y equals sine of x plus 3. This is different. This is not y equals sine of x plus 3. It's important that when you have that something being added to it, you either want to put it in the front, then there's no confusion. But if you put the parentheses in, there's never any confusion. Okay? So sine of x here's our 2 pi. Our midpoint is pi. Then we've got pi over 2, 3 pi over 2. And we normally start at 0. The midpoints and endpoints are the same. Pi over 2 is at 1. 3 pi over 2 is at negative 1. So I'm putting it in with a dotted line. Then I need to shift everything up. It's on the outside, so that's a C. That's a positive shift. We're going to go, every point goes up 3. So this one goes up 3 to here. This point goes up 3 to there. This point goes up 3 to here. This goes up to 2. And that goes up to 3. And the actual graph is higher. Okay. And I'll show you this in Desmos in a second. I want to show you the thing on the inside. Let's do one with cosine. And then we'll tinker around with it on Desmos real quick. So let's take a look at y equals 2 cosine of x minus pi over 2. So here a equals 2, b equals 1. There's nothing being added or subtracted to it. C equals 0. And d is the opposite sign of this. It's pi over 2. When it's negative on the inside, we move the graph right. So I'm going to make a little note of it. Move it right now. I'm going to go through and I'm going to plot 2 cosine x, then shift. So my points are normally 0, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Yeah, I know this simplifies to 0, pi over 2, pi, 3 pi over 2, 2 pi. But I think adding pi over 2 to this here is easier on the left. So we'll do that. So I throw in my first 5 points. 0 is obviously one of the points. This is pi. This is 2 pi. 3 pi over 2. Pi over 2. I'm going to write that as 2 pi over 2, and this is 4 pi over 2. And we're going to shift it right one, so I'm going to add in my next one, 5 pi over 2. I'm putting in both lines. The first one is a equals 1 or 1 and then 2. I'm doing that because when we have the vertical shift, it's helpful to have those lines there. So the base graph of cosine, at 0 and the end point, it's at a. And at the midpoint, it's at negative a. And the quarter points are 0. That should have been dotted. Now everything shifts right by pi over 2. And our graph does this. In fact, you'll notice if I had y equals, if I didn't have an amplitude of 2, if I had just y equals cosine of x minus pi over 2, that's the same graph as sine of x. Similarly, you'll find we could also do it where we do sine of x plus 2, or pi over 2, equals cosine x. The plus pi over 2 says we're going to shift left. So when we have it here, we shift it left. This is sine. It would go back there and would look like cosine. Sine x and cosine x are just phase shifts of each other by pi over 2. The horizontal shift is also called the phase shift. It's like a physics thing. They say it a lot in physics. Okay. Let's take a look at this in Desmos. So here's my graph of sine. And let's just see what happens. Here I've got H and K. K is like C, H is like D. That's how it was written in algebra. We used H and K. And that's why I have those letters there. Let's just take a look at what happens as we shift H and K. Let's do K first. That's what we talked about first. As k increases, the graph rises. See that? And as k decreases, it goes down. Okay. Let's set that back to 0. And now as h increases, remember we're doing x minus h. So as h goes up, when we think of something going up, it goes to the right on the graph. But here, watch the graph. H is positive. This is negative. This sign says negative, but as h goes up, it's moving in the positive direction. Let's get that up to the top so that as it starts going down, I can show you going the other way. So it's going down. Let's get to there. So as we go negative, now this is like x plus h, because the minuses cancel out, and now the graph is moving to the left. Okay. And if I just say this is pi over 2, and I plot cosine x, oops, sine's the opposite sign. Got to put a negative in. They're overlapping. Sine of x plus, this makes it plus, x plus pi over 2 is the same thing as cosine of x. And if I put that back in, and I change this to positive, and I make that regular sine, you see the same thing I said earlier. The first one I told you, when cosine is x minus something, x minus pi over 2 is the same graph as sine of x. So they do that type of stuff. And I'll leave that, come back to it. So it resets the stuff. We're going to do some cosecant, secant, tangent, cotangent in 6.5 and 6.6. That's why that's all in here. So let's go back to our work, our notes. And let's talk about what's going on here. The general rules for graphing these things. Strategy for graphing. Y equals sine, y equals a sine of b times x minus d plus c, or y equals a cosine of b x minus d plus c. Sometimes you'll see this as c plus a sine or c plus a cosine. And the reason why they do that is it helps eliminate any confusion. You really should put the stuff for the angle for the trig functions in parentheses or brackets. So, strategy. Step 1, we need to find our 5 marks. Find 5 marks. The endpoints, midpoints, and our quarter points. It's always based off B. They are at 0, 2 pi, or pi over 2b, 2 pi over 2b, 3 pi over 2b, 4 pi over 2b. If you learned them differently, you're allowed to do them differently, as long as you get the right graph. So put these slashes, find 5 marks, and place them on the graph. Give room for your horizontal translations. All of your translations. Two, make a note. Put dashes in. Put dashes on y-axis for y equals a and negative a. And you should do all dashes in steps of 1. So if you have to shift a lot, like we did in the first one, sine x plus 3, I had to go up 3. Having 3 dash marks in makes it easy to go up. This eases vertical translations. Three, graph with a dotted line, the base, not the base, with a dotted line, y equals a sine of bx, or y equals a cosine of bx. And finally, translate your graph, translate your 5 points, and draw a graph. Some people don't even do the dotted line. They just mark their 5 points. So if it's plus c, the graph goes up. Minus c, the graph goes down. If it's x minus d, the graph goes right. And if it's x plus d, the graph goes left. Those are our shifts. Okay. I'll give you, we'll do 5 more in here, and that should be enough examples to get you through this section. All right. Pause it if you need this up longer. Take a sip of my peach iced tea. All right. Let's take a look at some graphs. Our first one we're going to do, y equals negative 3 times sine of 4x plus pi. First thing you want to do, identify A, B, C, and D. Am I sharing the right thing? Yes, I am. Okay, so what is A, B, C, and D? A is the thing on the outside, that's negative 3. B is the value in front of x, which is 4. Right now, I don't have this written as B times x minus D in there. So I need to do that. So let's do that. The way we do that is you factor out the 4. Remember, when you factor out a number, you're basically dividing everything on the inside by it. This becomes pi over 4. 4x divided by 4 is x. Pi divided by 4 is pi over 4. Notice you can always check to make sure you did it right by redistributing. Does that get you that? Yes, it does. Now I look at my translations. There's nothing being added or subtracted to it. C equals 0. D is positive pi over 4. It goes in the opposite direction of the sign. The sign is positive. That would be right. So we're going to move left. So let's take a look at our part 1. Find the marks. We have 0, pi over 2b, 2 pi over 2b, 3 pi over 2b, 4 pi over 2b. When I put it in, I get 0. B is 4, so 2b equals 8. That's our new denominator. So I've got pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. That's what I'm going to graph with. It makes the horizontal translations easier. And the reason why is, what are we going to shift by? We're going to shift left pi over 4. If I want to get a common denominator with my denominators up here, I need a denominator of 8, which means I need to multiply by 2 over 2. I'm going to shift left by 2 pi over 8. And that makes it easy. I've already got hashtags in at each of these points. I know I just do the same equal distance hashtags on the other ones. So let's do this. A is 3, so I'm going to go up and down 3. And I'm going out to 4 pi over 8. So I'll do that as 4 pi over 8. And we're going to need to shift left 2 pi over 8. These are all in increments of pi over 8. If you do it this way, the horizontal shifts are easy. My base graph for sine, the endpoints and middle point are 0 of our 5 points. The first point, quarter point, is A, which is -3. The second quarter point is -A, which is +3 here. Do a little dotted line. And then I do my shift. I want to go left by 2 pi over 8. All of these are increments of 2 pi over 8. So this one over here, 1, 2, this is -2 pi over 8. The 0, 1 goes left 2. This one goes left 2, left 2, left 2, left 2. And then I'll draw this one with a solid line. And it would keep going. Okay. So D shifts in the opposite direction of its sign. This is really easy to screw up. The horizontal shift is the easiest one to make the mistake on. Take your time with it. It goes the opposite direction. Just like when we had graphing parabolas and stuff like that in algebra. All right, if you're ready for more, we'll do another. Let's take a look at y equals -2 plus 3 sine of 3x minus pi. Let's rewrite it in the correct form. We need to factor out that 3 right there. And that makes this x minus pi over 3. A equals the modifier on sine is 2. B is the coefficient on the inside is 3. C is the value being added or subtracted. It's -2. And D is the opposite sign of what's in here. It's pi over 3. This is a shift right. I wrote D is pi over 4 here. D is negative pi over 4 there. Okay? It's the opposite sign of what's inside. All right, so our points. 0, pi over 2b, 2 pi over 2b, 3 pi over 2b, 4 pi over 2b. What do we end up with? 2b equals 6. So that's our new denominator. And my shift to get the correct denominator, I'll multiply this by 2. This is 2 pi over 6. The other way of writing this in simplified form is 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. Doing a shift of d equals pi over 3 on these values is work. Pi over 2, shifting it pi over 3. I need a common denominator. Doing it this method gives me the common denominator right away. Okay? So let's do that. I'm going to be shifting to the right. I need more room to the right. And I'm going to be shifting down, so I'm going to make my y-axis bigger on the downside. So I'm doing increments of pi over 6. Right? All right, so my amplitude is, what the hell did I do here? My amplitude is 3. I wrote the wrong thing. A is 3 here. Let's make sure I'm sharing the right thing. Okay, good. A is 3. And I know I'm going to be shifting down 2 more, so I'm going to mark them now. My base graph is sine. So my endpoints are at 0. My midpoint is at 0. My quarter point starts at A, which is 3. And the second quarter point is negative A. Okay. Notice my dotted line is really, really faint. Now I do my shift. I need to shift everything right by 2 pi over 6. And it needs to go down 2. So this point goes right 2 pi over 6, down 2. That point shifted to there. This point goes right 2 pi over 6, down 2. Looks like I wrote my values on the wrong side of the graph, darn it. This one goes down 2 pi over 6, or right 2 pi over 6, down 2. This one goes right 2 pi over 6, down 2. Over here, down 1, down 2, puts us there. And finally, this one goes right 2 pi over 6, down 2. My endpoints and midpoints should be on the same line for sine. This is my graph. Notice if I didn't know A, the amplitude, reading the graph doesn't give it to me. Doesn't spit it out. My max here is 1. My minimum here is negative 5. And I had said do y equals 1/2 of max, or not y, a equals 1/2 of max minus min, which here is 1/2 of 5 minus negative, I'm sorry, 1 minus negative 5, which is 1/2 of 6, which is 3. And that gives us our amplitude, A. So getting the amplitude off the graph after it's been shifted, you want to look for that max value and that min value. Find the distance between them. That's what this max minus min gives us. It's a distance. And then we cut it in half to get the amplitude. All right, you ready for some more? All right. We've got y equals 3 minus 4 cosine. Let's do 5x plus 3 pi. Okay. Yeah, I made the, I put in a lot of weird numbers, didn't I? All right, what's the first thing we do here? Hopefully you rewrite that interior. We want to write it as something different. I want to factor out the 5. That should say 5 right there. And then I'll start writing down my values. A is the value in front of cosine. It's negative 4. B is the coefficient on x is 5. C is the amount being added or subtracted. 3 is being added. And D here is the opposite sign. This is like writing 5x minus negative 3 pi over 5. So D is negative 3 pi over 5. That's left. Okay? Which is the opposite sign here. This is a plus. Plus is normally to the right. So we're going to go to the left. Let's find our marks. And the reason why I write this pi over 2b, 2 pi over 2b, 3 pi over 2, I keep writing it down because I think if I do it enough, you'll start to see how simple the pattern is to use. 2b equals 10, which means I'm going to need this as a common denominator of 10. And I'm going to have negative 6 pi over 10 when I multiply by 2 over 2. So I'm going to be moving my leftmost point is going to be negative 6 pi over 10. So let's get this graph going. And I'm going to be shifting the graph up because C is positive. So maybe I'll make my vertical part of my graph bigger than or the positive portion of my y-axis bigger than my negative portion. I know I'm going to need 6 points to the left. If I plug in 2b equals 10, I got 0 pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10. A was 4 or negative 4. And I'm going to have to be shifting up 3. So I need to add 3 on the upper end. That'll be up to 7. This will be up to negative 1. That is 4 pi over 10. And if you do it like this, like if we were in class, hopefully a future teacher would allow it too. I would write these are increments of pi over 10. And then you don't have to make it crazy and try to write down every value. I'm going to wait to put in the other values till I see what my graph is going to look like. So let's see what we got. I'm doing cosine. So the endpoints start at A. A is negative 4. So my endpoints are at negative 4. My midpoint is at negative A. And my quarter points are at 0. Okay. I now want to shift each of these. I want to go left 6 pi over 10 or 6 dashes. And this is why I do all the increments in the same thing. Get a common denominator, do all the increments the same. It's easier to count and graph. I'm going to go left 6 spots, and I'm going to, C is 3. I'm going to go up 3. So this one goes left 6 over to here, and then up 3. 1, 2, 3. This one goes left 6. 1, 2, 3, 4, 5, 6. Up 3. 1, 2, 3. This one goes left 6. 1, 2, 3, 4, 5, 6. Up 3. 1, 2, 3. I know my next quarter point's at the same level as my first quarter point, and I know my endpoints are at the same height. So this is like this. It would be like that. Did I go too far? Yeah, I did. I should be down there. Okay. How you feeling? Well, those are some examples. Work through them. If you've got some questions, show up to the lecture hours during the summer. We're going to be doing Zoom hours during lecture time. Those are some examples. Oh, why not? Let's do a couple more. Let's do a couple more. Let's go with y equal, let's try this one. Y equals -1 plus 2 sine of 1/2 x minus pi over 2. So let's write it in the right form. I'm going to factor out the 1/2. And if I divide this by pi over 2, I should get pi. How do I check it? Multiply it back in. 1/2 times x gives me that. 1/2 times negative pi gives me negative pi over 2. So this tells me my amplitude is the coefficient on sine, is 2. B is the coefficient on x, which is 1/2. C is my vertical shift, is on the outside, is -1. D is my horizontal shift, it's the opposite sign. This is positive pi, which means we're going to the right. All right, let's find our marks. Pi over 2b, 2 pi over 2b, 3 pi over 2b, 4 pi over 2b. If I multiply b by 2, 2b, 2 times 1/2 is 1. Which means my marks are at 0, pi, 2 pi, 3 pi, and 4 pi. That's pretty nice. That's pretty nice. Definitely pretty nice. We're going to be shifting right by pi. And they're already in increments of pi, so I don't even need to rescale anything. This is good. I like this. This makes David happy. I'm going to be going down 1, so maybe I'll make my negative y-axis a little bit bigger than my positive y-axis. Two pi, 4 pi, slap another pi in there. My amplitude is 1 or 2. I get my hashtags in at 1. And I'm going to end up having to go down 1. So this is 2, 1, -1, -2. And I'm going to need a -3. All right, so what happens here? Sine at the endpoints is 0. And the midpoint is 0. The first quarter point equals a, which is +2. The second quarter point, it's -a, which is -2. Then we're going to shift everything. I'll put my dotted line in, why not? I need to go right by pi and down 1. These are in increments of pi, so just shift right 1. Shift right 1 on the x-axis and down 1. Right 1, down 1. Right 1, down 1. Right 1, down 1. Right 1, down 1. I missed that one. There we go. So this is y equals -1 plus 2 sine of 1/2 x minus pi over 2. As opposed to the very base graph of sine, which is this. That's y equals sine x. The 2 made it taller. This is less than 1, so it made it wider. This shifted it right. And that shifted it down. All right. All right, let's call that a wrap. Peace. This gets you through 6.4. I've got a couple more to do. 6.5, 6.6, 6.7. I'm going to make extra credit. It's some physics problems. I don't know that it's all. I think it was physics problem. I got to double check. Hold back on the extra credit on 6.7. I got to verify it. I haven't looked at it in a little while. Either way, peace. I'll catch you on the flip side.